So, this evening we have Professor Dipa Roy from Edinburgh University. Hers is the third talk in our mini-series on sort of plastics, recycling, new materials and how we're going to deal with things. She started with a BSc in chemistry and then other degrees in sustainable materials and a PhD. And I think she's a bit of a trailblazer really, because these are traditionally quite male occupations previously. So I think she's done really pretty well. And in fact in 2021 she got an award for, 50 influential women in engineering? Yeah. So I think they were women heroes in engineering, so we actually have a superhero speaker tonight, first one we've had. She's started off in Calcutta, went to Ireland, and now has been 6+ years at the University of Edinburgh. So I will hand over to Professor Dipa Roy, and please welcome her.
Thank you very much, Claire. So I'm really happy to be here today, and I heard about the society from Tom just a few minutes back, and it's a real pleasure for me to be associated with the society, such a prestigious society, and I'm really glad to be here, and hopefully we will interact after the end of the presentation. Okay, so this is a very informal presentation, and I will just share some of our research and also some of the thoughts which are driving our research in the direction of sustainable materials. Okay, I think some of you already attended some of the previous presentations on sustainability and recycling, plastic recycling. Just to give a little bit of introduction or background before I start my talk. So we all are very much familiar with the climate change and all the disasters happening, the natural calamities happening around the world. So basically this climate change is causing a change in increase in the temperature, and that is related to a lot of different types of consequences. We are seeing this water scarcity, fire, and rising sea level, and flooding. A lot of things are happening in the last few years. So before 10 or 20 years, no one really thought about this sustainability. No one really cared about sustainability. But with these things happening around us, suddenly these people are now much more aware that we have to do something. We have to stop this type of, climate change, and a lot of actions are now have started recently from different governmental, levels, and that is also spread within the society, within the community, within the research community as well. And one of the main route to tackle this climate change is to be more aware about the sustainability. So sustainability means we should do something which is more sustainable, which doesn't harm anyone in future, and which keeps things running in a smooth way without causing any problem for the future generations. And if we follow this sustainability, we can actually reduce the level of greenhouse gas, we can use our natural resources more sustainably, we can reduce our waste, we can have more biodiversity protection. So a lot of things can happen, but it will take time. But we need to do something on increasing the sustainable practices within ourselves. So basically, we are currently following this linear economy. You can see we are producing different materials, and we are manufacturing different types of products we are using, and when the end of life is there, we are throwing the products in the landfill or in the bin. So it's basically a linear economy. So we are producing more and more materials from nature and we are putting in the landfill. So that is a big problem. But what we have to do in order to bring more sustainability, we have to bring our practice in a more circular pathway so that we produce materials from nature, we use the materials, we again recycle the materials so that they are in a circular pathway and we are not then landfilling the materials and we are not causing harm to the environment. So that is the main driving force for sustainability. Now, whenever we talk about sustainability or recycling or waste, the first thing which comes in our mind is the plastic waste. Because all the time we are seeing these waste plastics here and there, and it is in the ocean, it is in the landfill, and there is no proper regulation or no proper system in place which can tackle these plastic wastes. So there are thousands and millions of different plastic articles we are using in our daily lives. So starting from very simple milk bottles to water bottles to thousands of things. And in order to produce these plastics, we are using huge amount of energy. So here you can see, this is you see million tons of energy, and for each production of each plastic, we are using 50, 60, 70 million tons of, yeah, thank you, millions tons of energy we are actually using for producing plastics. Now, after a little bit of service life, we are throwing the plastics. It means all the energy we are putting to produce the plastics are actually wasted. So that's why it is very important that whenever we are producing these new plastics, we have to make them use again and again so that all the energy which has been already invested in manufacturing these plastics, they should not go in the landfill. So that is a very, very important thing we have to keep in mind. Till now, we really didn't care about that, so we have used and we have just thrown it away. But this is the huge volume of plastics have been produced, and lot of millions and tons of production is associated with lot of energy consumption and also associated with lot of greenhouse gas emission. So whenever we are producing plastics, we are starting from fossil fuel up to a finished product. You can see at each step we have lot of production of greenhouse gas. Even for a thin carry bag, for a polyethylene carry bag, all these greenhouse gas emissions are there, and we are just throwing it like that. So all these have caused this much of deterioration of the climate and over many decades. And now we are at that point. We have to do something about it. I was trying to collect some of the information, how much plastics are actually recycled and what is happening with rest of the plastics. So the data shows that about 15 to 7% of plastic waste is only recycled. Okay, 58 to 60% plastic waste is incinerated. 14% is exported and 11% of plastic waste goes in the landfill. So a big portion of the plastic waste, which is close to 60%, is incinerated. It means it is actually burnt, and with that a lot of microplastics, lot of greenhouse gas is again generated. So this incineration is not the solution for reducing the plastic waste. But currently we are very much doing that. But if we see the greenhouse gas emission for plastics and if we compare that with other materials, we have an idea how much it is compared to other conventional materials. So still plastics is much less compared to iron, steel or cement, but the problem is we are throwing plastics all the time. It has lot of application of plastic is very short-lived, so it is causing a lot of problems. So these are some of the images we are always seeing in magazines, in news, in newspapers. So these are automotive plastic waste, biomedical plastic waste, packaging, many different types of wastes. Now, although these are waste, but we have to keep in mind that plastic plays a big role in the society. For example, in the biomedical field, lot of things are made of plastic. We cannot suddenly stop using plastics. We have to take the help of plastics in order to get the benefit of a lot of different things. But we have to use them sensibly, responsibly, so that whenever the use or the application is over, we have to do the right way what we need to do. Now, with all plastic articles, generally there are different types of symbols. I don't know if really all of us look at those symbols or not, but each plastic packaging has got some symbol. These are the different polymer or plastic identification codes. Each one has got a code, but there is no system that we can throw them in separate bins depending on what type of plastic it is. It doesn't work like that. It is not possible. So we put everything together as a plastic waste, and so all the plastics are then mixed up and the recycling becomes much more difficult. So when we put all plastic wastes together, it goes to the recycling centers. And there are many different techniques which can actually sort or segregate these waste plastics, but this has a lot of implication on the cost. So this is just one technique which can segregate the different type of plastic. So after some initial experimentation, they can find out which one is what, and they can go for recycling. But this step adds lot of cost. Plastic is not an expensive material, so it is a cheap material. And if there is a lot of cost involved in recycling, in identification, in segregation, it is not economically viable. So that's why people are just throwing the plastics in the landfill. They don't care, they don't want to recycle, because they can buy virgin plastic at a lower cost. Then why should they go for recycled material? So there is a big problem area here. So the plastics are actually getting accumulated in the landfill, especially the low value plastics, which we are using all the time in our daily lives. Now, plastics we are kind of familiar. Along with plastic, now I will also mention about another class of material which is plastic but reinforced with some other stronger and stiffer fibers, which are called composites. So plastics are more used in a lot of general purpose application, but polymer composites or plastics reinforced with fibers, they are used in higher end engineering applications. And the main advantage of these type of plastics or plastic based composites is that they are very lightweight. We can see plastic article is very lightweight, isn't it? So that's a big advantage of plastic. So when we make a composite, we have a plastic. Within the plastic we reinforce, we incorporate some high performing, high strength fibers. So the overall, the material becomes very stiff, strong but lightweight. So that is a main advantage of these type of composites. So these composites are now finding a lot of application in high-end engineering sectors, starting from aerospace to automotive to renewable energy, everywhere. You can see here the density compared to steel or aluminium. These are the two here. These are the densities of composites. They are much less. As a result, the overall, any article, if you make a large article with composite, it is very lightweight. So that has a big advantage in a lot of engineering applications. Now with composite, there are two examples which are very easy. Then we can easily understand what composite is. So in ancient times, in Egyptian history, we know the houses were built with mud. So the mud was reinforced with straw fibers. So the advantage is that mud has its own advantageous properties, straw fibers has its own properties. So both together give you some combination of properties which is useful for that application. Another very easy to understand example of composite is this concrete. We have the cement as the matrix or the binder. We have the iron rods, which are the main load bearing constituents. So this is also an example of composite. Very similarly, these plastic based composites are manufactured. So when we manufacture these composites, we have a plastic, and within the plastic we incorporate the fibers. The two most common fibers which are used in composites are glass fibers and carbon fibers. So these are the very commonly used reinforcement fibers for composites. Now both these fibers are expensive, especially carbon fibers. They are highly expensive and they are very lightweight and almost the highest performing reinforcement fiber for composites. So these are the two main reinforcement materials for composites. So when we manufacture composite, plastic is the matrix and the fiber can stay within the plastic matrix in many different forms. It can be continuous, it can be short fiber, it can be in many different forms. Depending on how the composite is manufactured, the properties are dictated by that. So some composite can go for aerospace, some composite can go for bridge, some composite can go for just some construction sector. It can have many different applications. Previously we knew aerospace is the main body of the aircraft, the primary structure, it is made with metal. But nowadays it is made, a lot of the part of is made with composite. Here also we have the plastic. This whole blue part is plastic reinforced with those carbon fibers. Now what is the main reason why these plastic based composites are getting so popular? The main reason is they are lightweight. So in order to achieve this sustainability, one very important thing is that we have to reduce the fuel consumption in transport sector. For that we need to reduce the weight. In case of aircraft, in case of electric vehicle, the weight reduction is important and these composites are getting more and more popular. So in some of the aircrafts of Boeing, it is more than 60% are this plastic composite which are reinforced with carbon fiber. This is a video. If I have time, I will play the video, how these are manufactured. Also, in another area, these plastic reinforced composites are getting very popular is the renewable energy sector. We see these wind farms everywhere nowadays, isn't it? In the renewable energy, all these long wind blades, wind turbine blades, 80 meter long, 100 meter long, 60 meter long, all are made with composite which has a plastic reinforced with glass fiber or some carbon fiber. So we can see the plastic is there in all low-end as well as high-end engineering applications. So the top one is a tidal blade, the below one is a wind blade. Also in case of transport sector, in automotive sector, we have all the high-end cars, sports cars or the electric vehicles are now having a lot of lightweight this plastic composite part just to reduce the weight. So we are having this everywhere. Now what to do then? The problem of recycling, the problem is still there. So on one side, these plastic composites are helping in sustainability. On the other side, there is a big problem at the end of life. What to do with them? So the main advantages we are getting with these plastic based composites, the first and most important one is lightweight. Manufacturing composite is much less energy intensive compared to metal. For metal, you may need 1000 degree, 1200 degree centigrade temperature. For a plastic based composite, you may need 200 degree, 300 degree. So energy wise, it is much less. Also, and they are corrosion resistant. You don't need any maintenance. So there are a lot of advantages, and also there is a potential for recyclability. Of course, the recyclability problem is not yet sorted, but if there is a way, we can recycle these materials. But the present situation is this. So these are the graveyards. So you can see on the top, on the left hand side, all the wind blades are, after decommissioning, the wind blades are there. It's a graveyard for wind blades. So we see the wind blades, they are really helpful, useful in generating this green energy. But what's happening when the life of the wind blade is over? So 20-30 years back, when these wind farms were new, no one really thought about what will happen after 20 years. So now all the blades which are decommissioned, they are now just sitting there. And huge focus at the moment is how to reuse these wind blades, because they are still strong, very strong, but they are not suitable for that application. So they are just decommissioned and put in the landfill. So that's a big area. So there are a lot of composite boats which are just not used, they are just dumped after the end of life. Similar thing is happening with the aerospace. So we are getting a lot of advantage with these plastic based composites, but at the same time it is creating a problem at the end of life. So we need technologies which actually can help to reuse these waste materials in another second generation products. So those technologies are still missing. That is one thing. Second thing is, even if we have technologies, we need a steady supply chain so that we know who will supply those recycled materials. Because I can start a product with some recycled waste material, but I have to get that supply regularly. But there is no systematic supply chain currently, no supply chain exists. So these are the huge problem areas which are very significant at the moment, and everyone trying to find some solution for that. Like many other research groups, we are trying to do some work at Edinburgh as well. So now I will show you some of the research work we are trying to do. So this is a collaboration with two industrial collaborators. So the first top one, I think we can all understand, these are all packaging plastic. They are all collected from Tesco. All are shredded into those fine, light, very fluffy shredded waste material. And below is, though you can see those big rolls, all those are glass fiber waste. So our industrial collaborators supplied us with that waste because those wastes are out of specification material, so they cannot sell it. So all these big rolls of glass fiber go in the landfill. So we actually got these materials, and then we thought how to use these two waste materials which are currently going in the landfill. Can we do something with this so that we can make a product, or we can develop a technology which can use these materials and divert them from landfill? Then we started working together with our industrial collaborators, and we did a lot of different trial, error, different types of experimentation. And we have published papers, so I'm not going in that detail. But ultimately, we manufactured some laminates, some composites. Composites means a plastic reinforced with that glass. So the plastic here was those shredded packaging waste, and the glass was that waste glass fabric from our industrial collaborator. And we got some quite good properties with those composites, in spite of manufacturing them 100% from waste. So you can see here the two figures, the two red dots. These are the composites which were manufactured with those waste materials. And here, this is the density, and we have the modulus and the tensile strength and the flexural modulus. And you can see, compared to a lot of virgin materials, our waste-based composites were quite good. We were quite surprised to see the good properties of these waste-based laminates. Now we tried to do some testing. So we wanted to find out where we can use these composite laminates. We need some application area. So first thing, when we are manufacturing the laminates, the composites, we saw they are very, very tough. They are almost unbreakable. We cannot break them. They can deform, but they will not break. Then we thought it's a very good property. Then we should do some testing which can take advantage of this toughness. We did some testing which is called high velocity impact test. The main purpose was to see whether we can use these composites in place of plywood for hurricane resistant application. When there is hurricane or some natural high wind, we protect the glass doors, glass windows with plywood, and plywood absorbs water. After one season, you cannot use the plywood again. And also in manufacturing plywood, you need a lot of adhesives which are not very environmentally friendly. So we are trying to see if our composites can be used in place of these plywoods. Then it will be quite good for the purpose because they are unbreakable. Whatever be the wind speed, nothing will happen. We can guarantee that. And also they will stay forever. They will not really get damaged with water or wind or anything. So we did this test, and these are some of the properties. I would like to just show one video. You can see this is a plywood. You can see this is the front side, this is the back side. You can see when it was a high velocity impact with the ball, the plywood completely, it penetrated. Whereas this is our material, you can see. It's the same, it's a very high velocity. It didn't have anything, no impact at all. This is another one. It cannot penetrate. And the plywood was almost 10 millimeter thick. Whereas these panels, these composites were only 4 millimeter, much thinner. We can easily increase the thickness if needed. But even less than half the thickness, but they were so much resistant. So it was really good to see, because there is a very good potential application for these type of waste-based laminates. Now, this work actually got, last year, it was named as one of the top 15 innovation in plastic by British Plastic Federation. So that's good, because our part is to attract industries who can actually take it forward for some application. Now in Edinburgh, we have a very good fire lab. I'm not sure if you know that, because fire lab is very well equipped fire lab in Edinburgh University. So we work together with the people in the fire lab, and with plastics, we all know fire is a big problem. So a lot of unfortunate incidents happen when we have a lot of plastic or plastic-based composite parts in our building. They can easily catch fire. So since we are trying to develop these composites for construction sector, we thought it is very important to make them fireproof. Otherwise, if needed, they will never be used in construction sector. So we did some, technologies. We applied some formulations and some veils, and we did some fire testing, and to see how we can improve the fire property of these laminates so that they can be used in real application. And this is how, there are two different technologies we developed with some formulation, with some other technology. So they were very different, and we wanted to find out which one is suitable for fire resistance property. And here you can see on the left, the red one. This is just the composite with the waste plastic and the waste glass. And a lot of heat is released when there is a fire. For the red, you can see it's a very, the longest is the highest value. Whereas with the two other modified composites, we could reduce the heat release. You can see the heat release is much less, and especially with the third one, the yellow one, it is much less. Also, when it burns, the composites actually, there is a mass loss, so it gradually burns off, so the mass is reduced with time. And in case of, we could see that it works very differently in case of our developed formulated laminates. So that's an advantage, because if we can modify the fire property of these composites, they can go in some real application in the construction sector. We also developed another type of composite. So with the waste glass, waste plastic, we also added one more recycled material in the composite, which is recycled carbon fiber. I mentioned about the carbon fiber a few slides back. It's a very expensive material. So a lot of carbon fibers are now recovered, and they are still high value. And we added a little volume percent of recycled carbon fiber with the waste glass and the waste plastic. And we could really achieve a lot of improved mechanical properties. And you can see this is a C-section which is used in the construction sector. Normally still C-sections are available in market, which is used in building for load bearing applications. And we manufactured some C-section in our lab, and the properties were again amazing. We were very surprised. We didn't expect the property to be in that range, but they were really very good high properties. So, but this C-section is completely 100% waste and recycled material based. There is no virgin material here. So these are some of the C-sections we developed, and we tested, with compression, axial compression test, and these are some of the values. You can see here that these three green bars, these are the values of our C-sections. This is the weight specific capacity, and these are all virgin material based C-sections, the orange ones. And you can see except 3 or 4 still C-section, the waste based C-sections perform really well. So there is a good potential of using these materials for in the construction sector, not only for non-structural applications but for structural application as well. So it makes a big difference, because whenever we are using these waste materials, you will see always it goes for our low performing applications, low cost application, low performance applications. And normally they are non-load bearing, just decorative type of thing, false ceiling, or where you don't need any loading, you don't need the strength. But with this type of combination of materials, we can actually get some very high mechanical property, and we can tailor the property, and we can achieve some reasonable good property so that they can be used for load bearing application as well. And the advantage of this type of composites is that they can be reshaped again and again. Whatever shape you need, you can do that easily, and after the end of life you can again recycle them. So it's a full circular way. So maybe the property may get a bit reduced, second or third recycling, but still it will be usable. So it's very important to have that circular pathway to make it use again and again. So when we got all these properties, we were surprised that these are all useful materials. We are just throwing in the landfill. All the materials we used here are currently going in the landfill. They have no application, but they have their own properties. They are good, they are very good. Like all the polythene bags we threw away, if we put them together, if we make an article, they will be very tough. We cannot break them. So they have their own good, inherent good properties. But we are not taking advantage of that. We are just putting them in the landfill or in the bin. So we are not, the problem is not with the plastics or the composites. It's more how we use them, how responsibly we tackle these materials. I think that's the main problem. Now, these type of waste-based composites have lot of application potential. So they can be used for hurricane-resistant panels, as I mentioned. They can go in automotive, in transport sector, because they are highly impact resistant. In car, in railway, we need materials which are very impact resistant, that can save life. So that has a huge, that can be a huge area who can absorb these type of panels, this type of composite materials. They can go for temporary housing because they are lightweight. Anyone can carry these materials. They can be, we can fold them, we can just open them, join them together and make a temporary housing. So there are different potential applications there. They can be made fire resistant and any shape, they can be welded easily. Lot of advantages are there. And another big point is that if we use these materials in the construction sector, they will remain locked there for many years. When we are using in packaging, we are just using, we are throwing. It's a short lifespan. But if it goes in a sector like automotive or construction, we don't throw things so quickly there. It remains 20 years, 30 years, 10 years, it will stay there. So there is a big, really good opportunity to think about how we can make, these things more within our products, within our kind of industrial line of products. And but there is a big challenge because of the supply line. I have discussed this a lot with different industries, but everyone first asks, is there a steady supply chain? So who will supply? If they start a production with these composites, they have to have the regular supply of materials so that they can continue their production. I think there is a big gap which is still not resolved. Now, what then we are trying to do with all these work? First thing is, now whatever engineering product we are manufacturing, previously it was designed to manufacture, but now it is changed. Now it's designed to recycle. So whenever we are designing a product, we have to know from the very beginning that at the end of life, how should we recycle the material? How should we recycle the product? It was not thought before. It wasn't really like this before, but now it's more designed to recycle. Second thing is recyclable materials. So first thing is the plastics, which we already discussed. So we are producing these plastics from petrochemical resources, fossil fuels, and we have to try to recycle them so that all the energy we have used up, all the greenhouse gas emission that has happened, everything is used to the maximum extent. They are not going in the landfill. That is one thing. Next thing is we have to use more natural renewable resources. So there is a lot of research ongoing to bring more natural polymers, natural plastics in market. There are some natural plastics, but they are mechanically much weaker. So they can go for some packaging type of application, which people are trying hard to bring those natural polymers for packaging. But they are still mechanically not robust. So we cannot use them for high performing engineering applications. So there is no option. We have to use general fossil fuel based plastics in high-end engineering applications, but we have to know how to recycle them, how to avoid them going in the landfill. I think we need to be more educated, all of us. We need to find technologies, and also there are a lot of obstacles in achieving this. So whenever we are generating these waste materials, there is no system to categorize the wastes. So if we are getting waste from a renewable energy sector, we are getting waste from automotive, we are getting waste from wind turbine, we are getting waste from aerospace. So all are mixed up. There is no way that we can categorize that these wastes belongs to this category. This belongs to this category. No system like that exists. There is no way to certify the waste materials. If we want to reuse the waste material, we need some certification procedure, because who will take that? They have to be sure that we are taking a recycled material, but it meets this criteria, so I can use it safely in my product. There is no certification procedure which is at the moment exists. As a result of that, there is a lot of uncertainty about the recycled materials. Everyone is scared. They think, will I use? The next batch may be different. How do I know how different it is? So no one is willing to take recycled materials in their product line. So there is a big problem. There is no market for recycled material. Because of these uncertain, quality of the material, there is absolutely no market. Even if someone does the recycling, no one knows who will take those materials. Lot of research, lot of efforts are now going to recycle these engineering composites. But still, there is absolutely no market to take these materials for second generation product. So the problem is still there. There is no solution yet. And we need regulatory compliance. Otherwise, it's only technologies or only materials will not help. We need some definitive policies from the government side. We need more regulatory. That's my timer. I should finish on time. So that's important. Another is industry awareness. So some industries can accept waste materials or recycled materials as their feedstock, but not all industries. For example, an aerospace sector, they're manufacturing the big fuselage. They have to ensure that the fuselage is the best quality, doesn't fail when it's in air. There is absolutely no compromise with the quality. They cannot take the recycled material to make their fuselage. They cannot. But they can use that maybe for some sitting interior of the cabin, or an automotive industry can take some recycled material for some interior of the car. So there are some industries, some type of products which are suitable for using recycled materials. But still, it's very gray area at the moment. No industries, they do not know themselves what they can take, what they cannot take. So it's not happening. Another thing is social acceptance or awareness. If we are buying a material, and if someone tells us, oh, it's a waste-based material, some of us, we will not care, but some of us might think, oh my God, I will go for a virgin. So, it's a mindset. So we need more understanding, more discussion within the society that these are waste, but they are not bad quality material. So they are going through some certification procedure, so we know they are good enough for next generation of application. So there are the gaps, and all research community are now trying to find different ways to find new technologies to use fossil fuel based materials, recycle these materials, bring more natural materials in all different way to make the economy more circular. So there we are at the moment. I just wanted to convey this to all of you. I think this is my last slide. Thank you very much.
If people have questions, please fire away. And if anybody wants this, would you like?
No, I probably can shout loud enough, I would say. Thank you very much, very interesting. You finished your talk with a list of problems, if you like. What you didn't necessarily do was to put them in any sequence where you thought which were the most important to solve, and the kind of cascade effect, if you like, because that really does give a completely different way of looking at it, because you can have some industrialists will come to you, and depending on what that cascade is, they will see an opportunity, particularly depending on what costs there are. So can you actually change your list around in any way and do that?
That's a very good question, actually. Thank you for that. So I think they don't really follow a particular sequence, to be honest, because they have to do, everything has to be done together, because if technology is generated or developed, unless there is a policy in place, it will not go forward. So everything, we cannot say that we have to do this first and then this is the highest priority, this is the lower priority. It's not really, we cannot define like that. Each and every problem is, I would say, equally important, because we need really some policymakers to take some action, to find out what policies are in place, what we need to make it happen. At the same time, people who are more on the, like environmental law side, they need to find out what are the environmental laws that need some amendment to accommodate all these issues. Same time, technologies are being developed by people who are doing research. So it's a kind of, they have to come together at some point. We need to link the missing things, but I think they all need to develop together. Otherwise, one thing has, but if the other thing is not developed enough, then it will not come in practice. So it's getting the research, or the efforts are happening in all different areas, very different group of people.
So what do you see as the umbrella that will actually hold that together and determine, right, if we know we've got this, this and this, then those other problems can be solved? Where does that umbrella come? Is it United Nations or somewhere like that?
So yeah, that's a very good question. Again, in EU, currently there are some more well-defined regulations which have come. They have stopped, they have kind of some stricter regulations, like they are stopping landfilling to a big extent. Still, that's not here in UK at the moment, but hopefully it will be very soon, it will come in practice. Like landfilling is being restricted, then people are trying to make sure that automotives are using at least 25% of recycled materials. So these things are happening, but I think they are happening much at a higher speed in EU regulations than in UK at the moment. But yeah, it's everything has to come together under one umbrella. You are very correct. Otherwise, we will not see the effect. Thank you very much for the question.
Okay, nice.
Yeah, sure.
Sorry. Tom.
Okay, I have a question. And if to excuse me if I don't formulate this very correctly, but I'm just thinking out loud. So, your very first kind of application that you mentioned there was the replacing plywood for hurricane protection. That's a little niche application, okay? Clearly it kind of looks as though it would work. it's an application that doesn't require particularly stringent specifications on the material other than the fact that it works. Okay?
Yes.
So it is something like that, potentially a first market that could be developed that has, let's say, in some way low performance specifications.
Yes.
But another way, it's got a kind of a killer specification, i.e. it's really strong and it works,
Yes.
yeah, that you could, say, develop first. Okay? Clearly, recycled materials are not going to get used in making fuselages for Boeing.
Yes.
But is there a simple application like that that could be developed?
Yes, you are absolutely correct. Because for the construction sector, we were targeting something which can be accepted easily. You know, that has less stringent requirement. You are very correct on that, exactly on that. Because especially in the construction sector, there are a lot of fire-related regulations. So when we first developed the laminate, we thought of something where the fire may not be that important, you know. So then, of course, we did some work with fire as well. That's a different thing. But yes, but that was the discussion we had. We should try something which can be accepted easily in the market, rather than, you know, something very critical, which has much more critical requirements and has to go through a lot more regulatory steps, you know, and hard to pass through with all the recycled materials. But yes, there are products which can be identified for the first, you know, range of products with these waste materials. Yes.
So what is that killer application?
So see, from our side, we tried to do some investigation or testing. You know, that was this high-speed hurricane-resistant testing as per some standard test method. So that was from the scientific side. We did that to see how it stands compared to, you know, other more conventionally used materials. So for that application, I think the most critical property is impact, how it can resist a very high velocity impact. So it depends on that killer thing. Depending on what product it is, we have to identify what killer property we can offer.
I was thinking that, if I remember rightly, you said that it was also waterproof. And I wondered about flood defence, which is something that we have concerns about in Perth.
Absolutely. I think that can be very good actually. You know, they are very easy to fit with one another and they are lightweight. Actually, we thought about it as well, you know, but we don't know where to go with this thing, you know, who to contact, but definitely this was something we discussed. Because it doesn't need, very similar to hurricane resistant thing, it doesn't need, you know, a lot of critical, you know, properties or something, you know, which are very difficult to get the certification or something like that. So they can be easily used for application like that. Yes, you are absolutely correct. Yes.
Could I ask a question about this hurricane composite? Have you considered end of life for it? You did say that the composite was indestructible.
Yeah.
So it would seem to me, looking at it in a very naive sort of way, that is both a positive and then an end of life a real negative. How do you build in to that material a reuse once its hurricane protection life is over?
Oh, I'll leap in and help you.
Oh, right.
I think Dipa said unbreakable as opposed to indestructible. Yeah.
Unbreakable, yes, they are very tough, so we cannot break them, that is correct. But what you were asking, yes, I will answer. So these materials are, when we heat it, they melt. So if the application is over, then we can again remelt, reshape it. It is possible. We can chop it, we can put in a machine where we heat and melt everything together and make it into another product. So that's an advantage of this type of plastic, polyethylene. You see, if we have polyethylene, if it comes close to a candle, you will see it melts. So the same thing for this type of composite. If its property may get deteriorated with time, but it can be again recycled into another new product by mixing with some other recycled materials, or just on its own. It's possible to remelt and reshape again and again. So there will be some deterioration with many cycles, but that will fit to some other application. Yeah, please.
I was just wondering if you're combining, this is sort of following on from what she was just saying, if you're combining the glass and the plastic, does that make it less easy to, like it has fewer options for what you do with it next, because it's hard, is it difficult to get them apart again once they've been fused presumably?
Very good question. This is a very good question. So here, since this plastic is, you can melt again and again, so even if it has glass, still we can chop or we can reshape. We cannot separate glass and plastic again, but we can again still reprocess them, because this plastic is melt, you can soften and melt again and again. But there are other types of plastics which are hard, we cannot remelt. There it's much more problematic, like the wind blades. It is a composite, but that plastic is non-meltable, you cannot melt it. So, and the fiber is there, so there the recycling is much more challenging. But with these plastics, polyethylene type of plastics, waste plastics, they are mostly, you can melt again and again. So even if it has glass, you can still remelt. The glass doesn't cause much problem. But you cannot separate the two. You are very correct.
And, sorry, I was just going to say, and also, obviously with the issue of plastics, recycling being really important, but there's also the issue of microplastics. But what you're working with is waste materials, so they'll be there either way. So I suppose at this point it is really good to be reusing them. But in terms of like long term, would you think that we should be using less plastics, using no plastics, and not having to use these kinds of things at all? Or do you think there's always going to be a need for these stronger materials for the kinds of engineering and medical things you're talking about?
Yes, I think it is not possible to completely stop using plastics. That's because it is used in so many different ways, and there are still a lot of applications where there is nothing which can replace composite or plastic. There are a lot of advantages. So I think that is difficult, but there are some areas where it is possible to replace these plastics. For example, in packaging. We can replace with paper packaging, we can replace with more biodegradable bioplastics. That is possible. But if we think about a very high-end engineering application, we have to go for fossil fuel-based plastic. So we can minimize, we can avoid using where we can avoid it. It's good to have that, kind of good understanding where we have to use, where we can avoid use, and if we have to use, how to make it less harmful for the environment, so that we can, we are not causing any damage to Earth. Yeah.
Can we, by any way, convert such plastics into industrially compostable one by mixing some additives or anything? Or, my question is, why the use of bioplastics or industrially compostable plastics are not, in the forefront? Is that a mechanical property challenge? Is that any other cost-wise challenge? What it is?
Yes, so some bioplastics are now coming into use, especially in the packaging sector. But there are two main challenges. One is the cost. Of course, the cost. Cost is much, much higher for a bioplastic compared to fossil fuel-based plastic. Second is the mechanical property. It can go for packaging type of application. It works very well, but not for high-end engineering application. So cost is a factor and mechanical property is another factor. So it's quite limited. Still till now, people are trying to develop bioplastics which have higher mechanical property, but the microplastic problem can still be there with the bioplastic, because when they are degrading in soil, they can still create microplastic. That is still under research. People are trying, because sometimes it looks like, since it's a bioplastic, it's produced from biomaterial, so it's safe. But still, I think we need a lot more understanding that when it biodegrades in the soil, in the composting environment, what happens? Does it completely break into carbon dioxide, water, mix with the soil, or there are some microparticles. I think that's still not well understood. So there are still quite a number of questions for bioplastics. Yeah.
Some of the high performance materials that you've talked about, is it possible to create them, say, using something? One of your slides showed boats, fiberglass boats, which is a huge problem.
Mm-hmm.
Is it possible to reuse something like that and create the kind of high performance material you're talking about?
I think that type of research is now happening. You are absolutely correct, because if we can reuse those materials after their end of life for some another type of application by some suitable modification, then it is absolutely, it should work well.
Good.
That is, people are trying in many different ways. For example, the wind blades. People are trying to make cycle shelters, pedestrian bridges, cutting these wind blades. So different types of research currently happening to make use of those materials. Because when these are discarded, they still have very good property, But since the same industry cannot use it, it's just going in the landfill. But some other industry can make use of it. So it's definitely something which is, definitely a lot of research is happening in that direction as well. Yes. Yes, please.
Yeah, you mentioned quite a lot of different types of plastic, and presumably because you're university research, you've tried a whole range of different substrates with the different fibres. Is there any one particular plastic which is a sort of front runner in these new materials?
In the new materials, is it?
In your materials, yes.
Yeah.
The fibre reinforced materials.
In fibre reinforced, I think we are more familiar with engineering thermoplastics, which are not in commodity application a lot, like polyamide, nylon. But nylon is much more familiar to us than in trade name. Polyamide or epoxy, which are very, very commonly used in composites sector. Yes, so polyamide is engineering thermoplastic, and some other thermoplastics are polyether ether ketone. So they are very high-end, expensive polymer, which are very much going in the composites for high engineering applications. Yes.
Okay, well you don't see many of those in the recycling bins.
In the recycling bins, they are still going. Yes. So a lot of people are now trying to reuse them because they are high value, but the right technology is still not there.
Right.
So research is a big research area, is that how to use these high value waste materials for next generation products. Yes, a lot of research ongoing in that direction.
Okay, thank you.
Yes, please.
Going back to the beginning with the hurricane protection and thinking as well about the flood protection, which is, as you've probably gathered, an issue in Perth. There is a company that makes small sections of, it's called box wall, and it's L-shaped sections that click together and are incredibly effective as far as flood protection is concerned. Now, to my uninformed eye, they look like petroplastic that they're made of, but I don't know this. But it would be a company that might be worth you having a look at in terms of a use, a practical use that you could put it to. Their website and a lot of the flood aid groups, the flood protection organisations use them because they are so effective.
Okay, that would be really very helpful to know the name of the company.
It's called Box Wall.
Box Wall.
Box Wall.
Okay. Definitely, I will look into their website. Definitely, yes. Thank you very much. I think these are the things we are always searching, where to go, who to contact. Yes, please. Yeah.
Clearly, the certification of this material, or any materials that are produced, is going to be crucial. But which organisation is going to certify these materials?
Yeah. That's again a very good question. Actually, we were in touch with NPL, National Physical Laboratory, regarding this. They don't do it, but we tried to contact them to find out who actually does it. But there is one body, I cannot remember on the top of my head right now, but there are some government bodies who can actually help in this type of certification. And also there are some government bodies again who do these test procedures for, normally they have done for virgin materials. There is nothing for recycled materials. But we need test procedures as well to suit, the recycled materials. So yes, so that we need, there are bodies actually who does it, but I cannot exactly tell you at the moment. But for one project proposal, we were in touch with them to get, we tried to contact them to, to have them in the consortium, because this is absolutely crucial, as you mentioned. Without the certification, there will never be any market. But there are well-dedicated government bodies who can actually do that, yes. But it wasn't easy to contact. I remember we contacted, we got a name and then we tried to drop an email, but of course within our time we didn't get a reply, it didn't happen. But of course, if time comes, I will again dig into that. But that is crucial, yes. Yes, please.
If you were looking for a low specification, large volume use for recycled plastic, here are 3. Traffic cones, pedestrian barriers, and buckets. They're made in enormous quantities,
yes.
And no one really minds about their performance. No one is going to die because the bucket fails.
Yes. No, that's a very good suggestion. Even if this type of huge volumes of products can consume huge volumes of wastes, So we always think about high-end applications, but even a low-end application can consume the wastes and can prevent them from going in the landfill. I think that is the main purpose, isn't it? It doesn't really matter if it goes for our automotive body or for a traffic cone. It's fine as long as it is not in the landfill. So definitely, it's a very good point you have mentioned. So if we get a company who can manufacture those cones or something, we are very happy to work together.
I think there is a company called Baltic who manufactures these road barriers and traffic cones from waste plastics.
Yes. Actually, Baltic is one of our collaborators from Ireland, and they manufacture those road barriers. Yeah. You might have seen when there is road works, there are some concrete type looking, very thick and bulky plastic barriers are there, which are plastic but they are very heavy. You won't feel like they're plastic, it looks like concrete and we cannot move them. So bulky and heavy, but yes, that type of things are currently being made, yes.
How difficult is it to move some of your research on to, actually being marketable?
Yes, that's again a very, very important question, because the work we did with these hurricane-resistant panels or C-sections, it was collaboration with industrial partner. So one of our partner was from US, okay, the glass fiber manufacturer. Their headquarters is in US, but they have a head office in Germany as well. Now, since they are sending these big rolls in the landfill, so they are very interested to find an application. So we had a joint patent with them, Edinburgh University and our collaborator. And they did a lot of pilot trial with their waste rolls of glass and packaging plastics, and they developed, kind of pilot scale trial and products, and they did a lot of market research, techno-commercial, viability study, because they have a lot of money. Our university, we don't have that. But they are a very good collaborator. They did a lot, and they tried to find a market in US. Till now, not successful. So they are still talking with different people there, but nothing yet. So they really wanted to have something because they can easily make in large scale, they can supply, they have their own waste, because when they make their glass fabric rolls, from each batch to another batch, there is a transition between the two specifications, and there is a huge thousands of tons of waste rolls generated. So they really want to have an application for those waste rolls, and because that's a sustainability carbon footprint credit for the company. So they really tried hard, I know, but in fact, sustainability didn't sell there, unfortunately.
Any more questions? Okay, would you like to do a vote?
Okay. I'll use the podium one.
Okay.
I don't know about you, but I thought that was really interesting. In fact, I thought all three of our talks on these recycled materials have been interesting. The science bit's interesting, but Dipa's last slide there, actually, was kind of really thought-provoking. The way that, sometimes I'm just thinking out loud here. We sometimes think about a solution in search of a problem. And here there's something similar to that. It's like there's a real problem, there must be a solution, there must be something that can be done, but clearly there are many obstacles to achieving that solution. Yeah? Economic, regulatory, it's complicated. And then we were thinking about possible applications, that killer application that I suggested. I like something like the flood protection. When we look at the gates in Perth, and you see that these are heavy, well, they're made of iron, aren't they, I guess? Yeah. And they take squads of workmen to install, and sometimes, apparently, the workmen aren't even there to install them. And wouldn't it be nice to have something that was lightweight, resilient, was going to do the job, and one little guy could come along with his truck and install them instead of a squad? There's got to be applications like that. And then I was thinking, I got the application. Wow, if you could just fill potholes with this stuff. Like, there's an infinite number of potholes, and it seems to me that every day there's more. If we could just take all this waste plastic and formulate it into something that was just squirted into a pothole to fix it.
Why not? That's happening actually. Bitumen mixed with waste plastic fibers, people are doing it, yes.
Really?
Yes.
Maybe you should get in touch with Perth Council and get them to fix the potholes outside my home. Anyway, sorry, I'm talking too much. I thought that was really interesting tonight. I loved your enthusiasm. Clearly, you have a passionate belief in your subject. I think I learned a lot, but I also realised that there's a long way to go before we have a solution for this recycling of plastic. Anyway, I can see why you hit the what was the 50 influential women in engineering. So good job. Thank you very much, Dipa. I enjoyed it a lot. I think everyone did. We round of applause.